So if we have a triangle, a right triangle, and we know that this side here is 3 and this side here is 4, we can find the third side by doing the Pythagorean theorem. Everybody remember that? So it would be 3 squared plus 4 squared equals c squared. And c is always the hypotenuse, so you need to make sure you put the side you don't have in the right place. If you're missing one of the sides, you would have a C, you would have an A or a B where the 3 or the 4 is. So you have to put things where they go. You can't just randomly put numbers down. So this is 9 plus 16 equals c squared, which is 25 equals c squared. This happens to be a famous triangle. I'll do an uglier one in a minute. And so the hypotenuse of this guy is 5. So let's find all the trig functions of this angle right here. We're going to name this angle theta. It's usually the one on the ground. We do not find the sine, cosine, tangent, secant, cosecant, and cotangent of the right angle. It's usually one of the other two. Well, it's always one of the other two. So we're going to say that we're finding the one for theta, where theta is the guy on the ground. Everybody get that? Theta is that. So I always put them in order: cosine of theta, sine of theta, tangent of theta. And then I put their cousins right next door to them. Get used to doing that so you know who goes with who. Cotangent of theta. Everybody see what I did? So if you look at theta, the cosine of theta is the adjacent over the hypotenuse. Well, the guy next to theta is the 4, and the hypotenuse is the 5. Everybody get that? Now, if you're looking at the sine of theta, it's opposite over hypotenuse. So what is the sine of theta? So it's 3 over 5. And the tangent of theta is opposite over adjacent. So that's 3 over 4. Any questions with that? So remember we learned that secant is the reciprocal of cosine. So this is really hard. It's going to be 5/4. The cosecant is the reciprocal of sine. It's going to be 5/3. And the cotangent is going to be 4/3. So I'm going to make up a really hard one here.